Chapter 6, problem number 22. A skier slides horizontally along the snow for a distance of 21 meters before coming to rest. The coefficient of kinetic friction between the skier and the snow is mu k equals 0.050. Initially, how fast was the skier going? Okay, this problem is very similar to problems involving determining the speed of a car that's skidded to a stop. Okay, where you can measure the length of the skid marks, you know the coefficient of kinetic friction, you can work back and figure out the speed of the car. Okay, so here we have the skier. Okay, we know the displacement of the skier is 21 meters. We know the coefficient of kinetic friction is 0.05. And a very valuable piece of information is that the final velocity of the skier is 0. And the unknown is the original velocity of the skier. So we're going to use the work kinetic energy theorem to solve this problem. So the net work is equal to the change in kinetic energy of the skier. What's doing the work is the force of kinetic friction. That does work over a displacement delta x. So we have the magnitude of the force of kinetic friction times the magnitude of the displacement, and then you multiply that by the cosine of the angle between those two vectors, which is 180 degrees. That's equal to 1/2 the mass of the skier times the final speed of the skier minus 1/2 the mass of the skier times the original speed of the skier. Now, cosine of 180 is -1, and Fk can be expressed as mu k times the normal force, where the normal force is equal to the skier's weight. So we have mu k mg delta x, cosine of 180 is -1, is equal to 1/2 m VO squared, because VF is 0, and there is a negative sign in front of that. So now we have a negative on both sides. So solving for VO, we get the square root of 2 mu k g delta x. That's because the m's cancel. So we have mu k delta x multiplied by 2 multiplied by g, take the square root of that, and we got the speed of the skier. So let's do the numbers. So we have 2 times 0.05 times g, we'll use 10 meters per second squared, and then delta x is 21 meters. Okay, so let's see what we get. .58, so about 4.6 meters per second.